work through a couple examples. So let's start off on practice exam A. And we'll start on problem 10, okay? So we're given some information here, right, about whether or not people are lying and lie detector results. So suppose that given someone is lying, the probability that lie detector says they're lying is 90%. So anytime we have questions like this, I think that the best way to approach this is write out what we're being given, okay? I'm going to see if I can, hopefully the recording of this will look okay. I'll get this as big as I can, just so I can start to identify what we have, okay? So the very first thing we're told is the probability that, what, given someone is lying, right? So the given is what comes on the right-hand side of that vertical line we're writing out probabilities, right? So given, right, and just to make sure, the L kind of looks like this, given that someone's lying, the probability the lie detector test says they're lying, so LD, I'm just going to use a shorthand for kind of the lie detector result. We're told that probability is, so it's 90%, so a probability of 0.9. I then have the probability, the next one is, however, given that an individual is not lying, so given, instead of not lying here, I'm going to write that they're telling the truth, but not lying, truth. Given they're not lying, the lie detector incorrectly determines that they are, in fact, lying 20% of the time, or a probability of 0.2. Okay? I'm then told recent studies find on average people lie about 5% of things they say. So the probability someone's lying is 0.05, right? That's all the information we were given right here for these next three problems, okay? So what's the probability that a person is lying and the test says they're telling the truth? Okay? Let me see a room here. So what are we looking for? So we've got all this information, right? And what we're looking for is the probability that someone is what? Lying and, so and the lie detector test says they're telling the truth, right? That's problem 10. So I've just written out the probability, like what we're looking for, okay? Now I'm gonna have to erase this, but if we have this written down, is everybody okay if I erase this? So this would be like at the top of my page, all right? If I'm looking for the intersection of two events, and I go to, where is it? It's hiding. I go to my formula sheet, and I want the intersection of two events. I can rewrite that as the conditional probability times what I'm conditioning on. So A and B, I can find the probability of B given A times the probability of A. So I'm just going to use that formula and write out, right, as a reminder, it's going to rewrite my intersection as a conditional probability divided, or sorry, my conditional probability times what I'm conditioning on, okay? So make this a little bit bigger for the video. But if this was my A and this was my B, the formula sheet said to take B, so the probability lie detector test says they're telling the truth. Rewrite that as given A, so the probability that they're lying. And then multiply that by the probability of whatever I'm conditioning on, which is that they're lying. Okay? So all I did there was write down what I'm looking for. I then went to my formula sheet. See, I can rewrite an intersection as a conditional times that I'm conditioning on. Once I had that formula, I then just wrote that out in the context of my example, right? So the general form in the formula sheet looked like this. So I just plugged my B in, plugged my A in. Now that I have this, I go back to what I was originally given. We had written down the probability of lying was 0.05. And we had that given that someone is lying, but probably the lie detector test says they're telling the truth. I don't think we were actually given that, right? What we were given was given that someone is lying. The probability the lie detector test says they're lying was 0.9, right? But if I know someone's lying, right? That's what I'm given. I know someone's lying. And the probability the lie detector test says they're lying is 0.9. Then the probability that lie detector test says they're telling the truth would just be 0.1, right? There's only two outcomes for this test. And so if I'm conditioning on the same state of nature, those conditional probability of those two outcomes have to add up to 1, right? And so this was one where, we could do those probability trees if that helped you kind of think about that in an easier way. I'll probably work through another one on Monday, another Bayes theorem. But the condition on the same state of nature, let me just make sure these are my conditional lines. The two different outcomes of the test, those would have to add up to 1, so we know this would be 0.1. So we plug those values in. 0.1 times 0.05 should just be 0.005. Okay. I'm going to skip 11. It's very similar to how you would do 10. And I'm going to go over 12 because I think it's a little bit more difficult. Also, let's make sure this, this is practice examiner. So, given an individual fails the lie detector test, what's the probability that they're actually telling the truth? So once again, I think the first part to start out, the first place to start out is, what am I looking for? So I'm told, given that someone fails the lie detector test, so given that the lie detector test says that they're lying, what's the probability that they're actually telling the truth? I think that's what it is. Yep. So what's the probability that they're actually telling the truth? Okay. Now, I wasn't given this probability directly. If we look back at those first three things we've written down, I didn't have that, right? What I did have was this formula sheet. And if I try to look at a conditional probability, I can rewrite it as the intersection divided by what I'm conditioning on. But in our example, our event B is that the lie detector test says someone's lying. So to have just the probability the lie detector test says someone's lying, I don't have that. I have the conditional probabilities, but I don't have the unconditional. So if I try using this formula, it's not going to work. But we can break that formula down into kind of Bayes equation, right? So this is going to be the one where once I have written down the probability I'm looking for, if it's a conditional probability, pretty good likelihood that if it, I was given a bunch of information ahead of it, probably going to have to use, you can kind of notice the practice exams have a very similar format. And so probably a pretty good example, I'm going to have to use Bayes equation here. But once I have this, I think about, okay, I need to identify my S and my E. So here's my S, here's my E, right? I would even just, oh, I just noticed this kind of isn't on there. Right, here's my S and here's my E. So I'm just going to write out this formula in the context of my example, okay? So what is my S? Well, my S is that they're telling the truth. So I'm going to take the probability that someone's telling the truth, multiply that by the probability of E given S. So my E is that the lie detector test says they're lying, given S is that they're telling the truth, right? And then I'm going to divide this by, right? So I'm going to divide this by, notice the first part of this denominator is the exact same thing as the numerator, okay? So I would write that down again. Well, I can try to make it, it's going to be small so I save myself enough room. But you can imagine it's just the exact same thing as the numerator, okay? So I know it's a little bit small here, but what you have in the numerator will be what's down here in the denominator, okay? The second part of that denominator is the probability of S complement. Well, if our S is that they're telling the truth, our S complement would just be that they're lying, right? And then multiplied by the probability of E given S complement. E was that the lie detector test said they're lying. Given S complement, that was just the probability that they were lying, right? So I now have this equation written out in the context of my example. So just to kind of make this a little bit bigger for those of you who watch the video afterwards, right? I now have base kind of equation written out in the context of my example, and I can start plugging things in. If I go back to those first three things that I originally wrote down, what was the probability that somebody was lying? 0.05. The probability they were telling the truth, we had, didn't directly have that written down, but right, if I know the probability someone's lying is 0.05, probably they're not lying or telling the truth is 0.95. We had all these conditional probabilities written down as well. So just remind me, given that they were telling the truth, what was the probability the lie detector test incorrectly said they were lying? Are any of you writing this down with me? It was like 20%. Yeah, we had that written down as 0.2. And then given that they were lying, the probably the lie detector test said they're lying, I think was it 0.9 we had written down? And now I've got a bunch of numbers. It's just multiplication, addition, division, making sure I do my order of operations correctly, right? So write down the probability of what you're looking for, then put an S and an E over it. Then go to your formula sheet, write out Bayes' equation, substituting in for S and E, whatever your S and E are. And then if you had written those first three probabilities down from the information given in the problem, well, now it's just a matter of plugging those things in where they belong, right? Any questions on that? I think this is probably one of the harder questions on, maybe the hardest question on the exam is these Bayes ones. Just because it's a lot of information you're given that you have to write out the probabilities. I don't know. I just think for whatever reason, it tends to be the one that people have the most difficulty with. So if you're wanting more practice on it, right, first of all, what we did here in class today, I'm going to cut up part of the lecture into a little video so people can kind of see me work through these two questions. But also